Welcome back, guys. In our second video today, we are going to talk about how we can determine the limiting reactant and therefore the amount of product we are going to produce by counting individual atoms and molecules. So let's first carry this out without doing any sort of math. Here we've got a chemical reaction equation where we have H2 molecules combining with oxygen molecules to form water. The first thing we want to do when we're given a chemical reaction equation is to make sure that it is in fact balanced. As you can see here, there are an unequal number of oxygen atoms on both sides. So we're going to have to introduce stoichiometric coefficients to balance that out. And balancing oxygen, we see that we unbalance our hydrogen, so we're going to have to put a stoichiometric coefficient of 2 in front of both the hydrogen and water, and we have a balanced chemical reaction equation. So now we're ready to use this chemical reaction equation to figure out how many water molecules we are going to form given some initial layout. Okay? In this case, we have a total of 2 H2 molecules and 3 O2 molecules. So, according to our reaction equation, every molecule of H2 that's used up to form a water is going to use one oxygen atom. So if I cross out 2 hydrogens and 1 oxygen here, we are going to form, in our products flask over here, a single water molecule. A little further apart. Okay, so that's our first water molecule. Now, of course, there are still reactants left over here, and we can use these reactants to continue this chemical reaction, forming additional water molecules. So doing the same thing again, we will cross out another pair of H2 molecules and another oxygen atom, forming yet another water molecule. All right. So now we have a total of 2 water molecules formed, and looking at our initial flask here, what do we see? Well, we've used up all of our H2. There's no H2 left, which means the chemical reaction is going to come to a stop. So in addition to the 2 water molecule products that we've formed, we are going to have 2 O2 molecules that are going to remain in our reaction flask unreacted. So we'll just draw them in right like this. Now, what we want to be able to do is answer this question, right, without having to carry out this somewhat tedious process of crossing off individual atoms, drawing out individual molecules. So we're going to introduce some mathematical techniques that will essentially allow us to answer this exact same question. To do that, what I want you guys to start off with is basically writing out the number of H2 and number of O2 reactants that you have. And then we're going to solve the hypothetical problem that essentially amounts to completely reacting all of the H2, then completely reacting all of the O2, figuring out which one creates the least amount of water, and that will give you your answer. Right? The one that creates the least amount of product will be our limiting reactant. So let's go ahead and move forward with that. Maybe get a little bit more room down here. So we'll start off first with our H2 molecules. And we've got 2 of them. Okay? So our first task now is to convert H2 molecules ultimately into product molecules, H2O. So to do that, we need to construct a conversion factor that's going to take us from H2 into final units of H2O. Okay? So in order to get the units of H2O at the end of the day, we need the unit on the bottom to cancel out our H2 and the unit up top to be H2O. So the conversion factor we're after is basically a ratio that we obtain from the balanced chemical reaction equation that tells us how many molecules of H2O are formed per molecule of H2 being used up. And these numbers, this ratio, comes none other from the stoichiometric coefficients. So the stoichiometric coefficient for H2 is 2. The stoichiometric coefficient for H2O is again 2, effectively giving us a 1-to-1 ratio. And so taking our initial amount of 2 H2 molecules, multiplying by 1, gives us 2 water molecules, which, if you look at our reaction flask over here, we've got a total of 2 water molecules floating around in there. Now, let's go ahead and carry out this same process down here for the H2 or the O2 molecules. Now, how many O2 molecules do we have? Remember, we're starting off with 3 of these guys. So if we've got 3 O2 molecules, our task now is similar to above. We need to convert from units of O2 into units of H2O. So the conversion factor, once again, is going to have H2O up top. But this time, in the bottom, we are going to want to have our O2 molecules. So now our conversion factor is going to be built from the stoichiometric coefficient for H2O, which is a 2, and the stoichiometric coefficient for oxygen, which in this case is a 1. And remember, there's always an implied 1 there. We typically don't write it out for simplicity of the written expression, but there is a 1, so we'll carry down that 1. And now, when we carry out this expression, we're going to take 3 times 2 to give us 6 H2O molecules. So what we conclude from that is that hypothetically, if we react all of our H2, we get 2 water molecules. Hypothetically, if we react all of our O2, we get 6 H2O molecules. Well, of course, 2 is less than 6, which means the H2 is going to get used up first, and as a result, this guy is going to be our limiting reactant. Okay? So H2 is limiting. Okay, that's limiting. And once we determine our limiting reactant, we can also identify how many product molecules we're going to form by just looking at the other end of the expression. So we will form 2 H2O products. And in this way, we've effectively reproduced what we determined initially by essentially crossing out individual atoms and molecules. But now we've built up some machinery that's going to allow us to solve essentially more complex problems rather efficiently, as you'll see in the next video.